My name is Tinus Stander. I am a professor in the Department of Electrical, Electronic and Computer Engineering at the University of Pretoria. I'm the principal investigator in microwave electronics at the Carl Emily Fuchs Institute for Microelectronics. Most of my research focuses on radio frequency, microwave, and millimeter wave systems and components. The most significant application of our current research is in radio astronomy, where our research is supporting the operations of the South African Radio Astronomy Observatory, but also other international projects, such as the African Millimeter Telescope, as well as Project Atlas, which is a new proposed 50-meter telescope build in Chile. Our contributions are mostly related to broadband receivers for these systems, where we are developing new ways to integrate components at cryogenic temperatures. Another significant interest for us is 3D printing of radio frequency systems. Here, we work closely with our collaborators at the Fraunhofer Institute in Germany, as well as EPFL in Switzerland. We are characterizing new kinds of 3D printed materials for their radio frequency and microwave properties and applying those in novel 3D printed designs. We also do some work in built-in self-testing of radio frequency components and microwave components to make them more reliable in harsh environments, such as in space. A specific interest for us is the design and deployment of water vapor radiometers. The problem with millimeter wave astronomy is that it is impeded significantly by atmospheric water vapor. So to build a new millimeter wave site requires extensive characterization of the area and the atmosphere for water vapor prior to making a build decision. Our lab is working in collaboration with several institutes around the world to develop new, cheaper instrumentation to measure the water vapor concentration in these proposed sites. Some of you may be familiar with the images of the black hole that were taken a couple of years ago. That was done with a global network of millimeter wave radio telescopes, because black holes can only be resolved with very large distances between telescopes and very high frequencies. It is our hope that we can help characterize new sites for millimeter and sub-millimeter astronomy in Southern Africa. My road into RF and microwave electronics led through defense technology. I was sponsored for my master's and PhD by Reutech Radar Systems in Stellenbosch, for whom I designed a new kind of broadband absorptive filter for their radar systems. After completing my PhD, I joined Denel Dynamics in Centurion for a couple of years, where I was a staff RF engineer working on a variety of communications and guidance systems. I joined the university in 2013, initially as a senior lecturer, and eventually be promoted to full professor 2 years ago. No one in the country can do what we do. We have very unique manufacturing and measurement capabilities in South Africa and in sub-Saharan Africa and in the global south. The road into microwave electronics and electromagnetics starts with embracing ambiguity. Many people are familiar with digital electronics and computers and software programming, where the inputs and outputs are always related by very well-known deterministic rules. In the field that I work in, that is no longer the case. The relationships between what you put in and what you get out are sometimes very obscure, and you have to embrace that exploration. So if you like building circuits without knowing exactly what will happen if you switch it on, then maybe analog electronics is for you. There are ubiquitous and evergreen challenges in my field. The greatest of them is definitely wireless communications, where the insatiable demand for data and data transport is moving communication channels to higher and higher frequencies, requiring wider and wider bandwidths of operation. There will always be challenges in translating technologies and techniques and circuits from low frequencies to higher frequencies where wider communication bandwidths are available. The greatest new challenge in this regard would be 6G telecommunications and beyond, where communications and other applications such as automotive radar have to coexist seamlessly in dense urban environments. Our interest in additive manufacturing stems from its value as a low-cost, low-volume production and rapid prototyping tool. 3D printing is an excellent way to manufacture something where it is needed, when it is needed, without relying on long logistic systems to get a part to a product. We believe that 3D printing is a way to make the manufacturing of radio frequency and microwave components accessible to everyone that needs them, wherever they need them, whenever they need them. A lot of our research in this regard deals with making the materials better suited for their application and making the components created with them better suited for the systems they operate in. I get weekly emails from employers in Gauteng and nationally asking for graduates in radio frequency electronics to join their organizations. Most of these calls are from defense technology companies around Gauteng and the Western Cape, but of late, I've also been receiving calls from abroad. The global demand for radio frequency and microwave engineers is insatiable. If you are curious about the world around you and brave enough to explore it, join my team and make today matter.